Good afternoon, my YouTube viewers. Crystal here. What I'm here this afternoon to show you is my solution to an analytics VidHide competition question. It was for their Indian Independence Day Hackathon. And basically, I'll read you the problem statement. The problem statement was researchers have access to large online archives of scientific articles. As a consequence, finding relevant articles has become more difficult. Tagging or topic modeling provides a way to give a token of identification to research articles, which facilitates recommendation and search process. Given the abstract and title for a set of research articles, predict the topics for each article included in the test set. Note that a research article can possibly have more than one topic. The research article abstracts and titles are sourced from the following 6 topics: computer science, physics, mathematics, statistics, quantitative biology, and quantitative finance. So then what we have to do is we have to go through a series of steps in order to solve this problem. So, and we've got written down here the list of steps that we have to go through. 1 is loading the required libraries and modules. 2, loading the data and performing basic data checks. 3, pre-processing raw text and getting it ready for machine learning. 4, creating training and test data sets. 5, convert text to word frequency vectors and TF-IDF vectorize. And 6, create and fit the classifier. 7, computing the evaluation metrics. The following sections will cover these steps. So basically, we've got number 1, loading the required libraries and modules. So I loaded all the modules that I would need and then some, because I don't think I needed Snowball Stimmer. But basically what I had to do is I had to do a lot of studying and research on this to fix the problem. And finally, I was trying to use the tweets, because I had previously done analyze the tweets problem, and I was trying to use the tweets, but that wasn't really suitable because this isn't a tweet. And so I was looking on the internet. I was trying to try to find ways to analyze the sentiment by web scraping and everything else. And one of the other participants in the Indian Independence Day Hackathon was kind enough to send me his code. But since he's been working at this a lot longer than I have, he knows a lot more about it than I do. And the code that he used was quite convoluted. Like, he was doing a lot of things that you have to have a lot of experience to do. So I did actually end up using the model, but other than that, I did everything myself. And I got this one article. I found this one article on the internet. It's this article right here in green. And that gave me a tremendous amount of help, because the article was similar to this problem statement. And so I was able to use the basis of that article to help me to complete this problem, which is what I'm showing you now. And I got about an 81% accuracy on what I did, which was only 2% lower than the 84% accuracy than the person who sent me his code. So I did a lot less work for just 2 percentage points less accuracy. So I'm okay with that, except for the fact that I was reading an article today, and when you're and when you're in the world of work, they want your accuracy to be at least 90%. So I've got to try to get my accuracy up to 90% from now on. So I'll be able to enter the world of work with a very high accuracy rate. So 90% is what I'm going to be gearing for from now on. So after my libraries, what I did was I loaded my CSV files. We had 3 CSV files: train, test, and sample submission. And then I pulled those up as well. So you can see the train file. The train file's ID number, a title, an abstract, and you've got 6 columns that are binary for what genre the book fits into. And the book can fit into more than one column, because you've got one on number 5 here. The book is computer science, but it's also statistics. So that's why you have to have the 6 columns. So just in case one book falls into more than one class. We've got more than one class several times, because like on the end one here, 20970, it's in mathematics and statistics, and 20971, it's in mathematics and statistics as well. So that's why we had to have the 6 target columns. We looked at the test file. The test file only has a title and an abstract. And we looked at the sample submission. The sample submission only has an ID number and the 6 columns for the outcome. We checked to see if we had any missing values, and no, we did not have any missing values. And then what we did was we did a series of group bys to see what percentage we had of each outcome. So on the computer science books, approximately 41% of those were computer science books. Were yes. And the physics books, approximately 29% of them were physics books. The maths books, approximately 27% of them were maths books. The statistics books, approximately 25% of them were statistics books. The biology books, approximately 3% were biology books. And quantitative finance, approximately 1% were quantitative finance. And it's interesting to note, because I got my master's degree in finance and I had to study quantitative finance. As you can see, I didn't go very far with that degree. The next thing that we're going to do is we're going to pre-process the raw text and get it ready for machine learning. So what we did was we put it on the Porter stemmer function, and we also set up our words as our word stop. So we put the train process data equals train abstract into the Porter stemmer function, and text process text equals text abstract into the Porter stemmer as well. And what's interesting to note here is that I tried to combine the abstract column and the title column, hoping that it would give me a better accuracy, but it didn't give me a better accuracy. It actually decreased my accuracy. So I just stuck with the abstract column and didn't worry about the title column, because that was making my accuracy lower. And that's another problem that you have when you're writing these computer programs. The more work that you do on your data set, the more noise that you generate. And so that's another thing that needs to be taken into consideration, because there are people who are a lot better programmers than I am. They've been doing it for a really long time, and they know a lot more than I do. And they know a lot of they put these bells and whistles into their programs, but because they're putting so much into their programs, they're introducing a lot of noise into their programs, which is going to decrease accuracy. The next thing we did was we made all of the text lowercase. We removed any special characters. We removed any words that were less than 3 characters. And then I just used a little function to show you a picture of all the words that were in the abstract. So I'm not going to change the coding, but I said title words because at the time I was going to do the words in the title and the words in the abstract. But then when I decided not to use the abstract, but this is all your title, were all the words in the process text, which is really the abstract, even though it says title words. I mean, I could, if I wanted to. Just to be a little bit more clear. Just to be more clear. So people know it's the abstract column we're dealing with. So the next thing we're going to do is we're going to convert the binary columns to category. So your target has 6 columns of computer science, physics, mathematics, statistics, quantitative biology, and quantitative finance. And that's your target. And your Y data equals your trained target. And then we make a little graph here. And what this does is it shows you what the percentage of ones is. And so you can see computer science is the first, physics is the second, mathematics is the third, statistics is the fourth, quantitative biology is the fifth, and quantitative finance is the sixth, which is interesting again, because that's what I've got my master's degree in finance and Master of Science in Finance, and there's not very many books on the subject. And so I gave one of my boyfriends one of my old books to sell on eBay, and somebody bought it because there's not very many books on the subject, and they are quite expensive. The next thing we did was we created the training and test data sets. So the first thing we wanted to do is we wanted to find our X, Y, and X test variables. So Y equals train target, X equals train process text, and X text equals text process text. And what we've done is we've broken our train data down into 4 sections: X train, X val, Y train, Y val, using train test split, using X, Y. We're going to have a test size of 10%, random state 555, shuffle equals true. We wanted to see the shape of our columns, because you always need to keep an eye on the shape of your columns. And X train is 18874, X val is 2098, Y train is 18874, and Y val is 2098. So you always need to keep an eye on the shape of your training file. That helps you in the long run. The next thing we need to do is we need to convert our text to word frequency vectors. And I converted the word frequency vectors. But one thing to keep in mind is there's lots of ways that you can analyze text. And I was trying to use some other ways to analyze text, seeing if that would improve my score, but it didn't improve my score. It actually made my score less. So there are other things that you can add to this program, but what I found personally was it had the effect of making my accuracy less, so I didn't include them. So what we did was we created a train TF-IDF, which is fit, transform, X train values as type U, a val TF-IDF, which is vectorized TDIF, transform X val values as type U. We did an X test TF-IDF equals vectorized TF-IDF, transform X test values as type U. And then we printed that out. So that's interesting. So up here we've got a fit transform, and we don't have the fit transform anywhere else. So I think I'm going to have to investigate that and find out why there's a fit transform in only one variable. It's very interesting. Maybe it will increase my accuracy. The next thing we have is we printed train TF-IDF shape and val TF-IDF shape. And so we had 18,874 and 2098. And each of them had 28,090 columns. Then what we did was we define and train the model. And so we imported linear SVC, but we also imported multi-output classifier because we've got 6 columns in our output. So this is a multi-class output. So model equals linear SVC, class weight equals balance, C equals 0.5, and models equals multi-output classifier model. So we fit our model. Models fit train TF-IDF Y train. And we make our prediction. Preds equals models predict val TF-IDF. Pred SSV equals models predict X test TF-IDF. We checked our accuracy, and we had an 81% accuracy. We prepare our submission, and you can see that we had 1 column for the ID column and 6 columns for your output. And we submit that to Analytics VidHaya, and I got about an 81%, which was 2 percentage points less than the guy that sent me his code, and his code was 83 something or other, making it almost 84. And he did a lot of work. He did a lot of moving things around and a lot of things that I didn't understand because I haven't been programming as long as he has. So he knows a lot more than I know about it. So that concludes this solution. And this solution definitely will get you on the leaderboard, and maybe, maybe needs some more work to see if we can improve the accuracy, because from what I was reading today, we need to get a 90% accuracy if we want to make it in business. So that's what I'm striving for from now on, a 90% accuracy. But this will get you on the leaderboard, and it's quite respectable. If you like my video, please like, subscribe, and share. If you have any comments, please leave your comments in the comment section down below. If you like the work I do and you want a donation, I've got my email address to my PayPal account in the description. And because I don't have enough subscribers, so I don't get monetized, and the only way I can make any money on this site is to ask for donations. And thank you so much for watching this video, and I look forward to making the next one for you.